Good morning, class 12th. Now in this lecture we will learn how to calculate the oxidation states of the central metal atom in the coordination complex. So the calculation for oxidation number is very important for the coordination compound, because in the upcoming lecture I will define the VBT, the valence bond theory. So valence bond theory plays an incredible role for defining the paramagnetic character and hybridization and so many other properties of the complex compound. So the oxidation state will be the first step for the VBT for defining the shape and the hybridization of the complex. So oxidation state is very important. So how to calculate oxidation state? It is very simple. For example, this is first complex K4FeCN whole 6. So we have to calculate the oxidation state for the central metal atom. Always we have to calculate the oxidation state for the central metal atom. For example, we can break this complex into 4K and plus. Let the oxidation state of iron be X. This is X and plus 6 into cyanide. And the overall complex will be neutral. So equals to 0 because overall charge is 0. Then we have to put +1 for the potassium, because potassium is from the first group element and the valency will be +1. So according to the valency we have to put the digits, and X is the oxidation state for iron and 6, and then Cn negative. The charge for Cn species is -1, so we have to put the charges of that particular species. Now simple calculation is there, +4 and now plus X, 6 into -1 minus ka 6 equals to 0. Now X minus 6 plus 2, yes, minus ka 2, and X minus 2 equals to 0. So X equals to +2, means the oxidation state of iron in this complex will be +2. We have to mention this plus sign, because always we have to mention plus or minus sign for the oxidation states, because valency, there is a big difference between the valency and the oxidation states. Now second is the example, the second complex, the name is potassium ferricyanide. This is potassium ferrocyanide and this is potassium ferricyanide. So we can break this complex into 3K plus let the oxidation state of iron be X plus 6 cyanide. The overall charge will be 0 because molecules are neutral in nature and this complex is neutral. Now same to same, 3 for potassium plus ka 1 plus X plus 6 into for cyanide minus ka 1 equals to 0. Now simple calculation, +3 plus X, 6 into -1 minus ka 6 equals to 0. Then X minus 3 equals to 0, or X equals to plus ka 3. So in potassium ferrocyanide the oxidation state of iron is +2, and for potassium ferricyanide the oxidation state is +3. Now in this type of complex, let oxidation state of iron be of zinc be X. So X plus 6 now charge for water molecule, and now equals to not 0. Now this time the overall charge is +2 for the species. So the overall charge for this species is +2, so we have to put plus ka 2 in this side. And for the first example, now the overall molecule is neutral, that's why we have to put 0, the overall charge for this species. Now in this example the overall charge is plus ka 2, that's why we have to put +2 on this side. Now X. So what will be the charge for water molecule? The molecule has 0 charge, so this side 0 equals to +2. Charge will be 0 for the water molecule because water is a molecule, neutral molecule. Now X plus 0 equals to plus ka 2. Now the oxidation state will be +2. So in this complex, zinc is in +2 oxidation state. Now for this type of complex, same to same, this example, let the oxidation state of cobalt be X and plus 6 into water molecule equals to plus का 2 charge, because the overall charge for this complex is plus 2, so we have to put plus 2 sign. Now x plus 6, the charge for water molecule is 0 and equals to plus का 2. Now x equals to plus का 2. Now the same, the oxidation state for cobalt for this complex will be plus का 2. It is quite simple. Now for this complex, let's the oxidation state of cobalt be X and plus 4 into Cl, and the overall charge will be this side, the overall charge is minus का 2. Now X plus 4. Now what will be the charge for chlorine? So this is minus 1. This is from 17 group, fluorine, chlorine, bromine, iodine. They all having minus 1 charge. The valency is 1, but we have to put the oxidation state. Don't forget to put the sign for the oxidation state. Without the sign, it is incomplete. So we have to put the sign firstly. N equals to minus का 2. Now x 4 into minus 1 minus का 4 equals to minus का 2. So x equals to minus 2 and plus 4. That means plus का 2. So cobalt is in plus 2 oxidation state in this complex. Now the second example, the example number 6 is nickel NiCO whole 4. So very simple, let the oxidation state of a nickel be X. So X plus 4 carbon monoxide. Now the overall charge will be, just think, the overall charge will be 0 because it is a neutral molecule, neutral species, so overall charge will be 0. This side the overall species having the minus 2 charge, that's why we have to put minus 2 this side. So this is very important step. Okay, so X plus carbon monoxide is a molecule, so the charge will be 0. So the overall oxidation state will be for X plus 4 into 0 means 0. X plus 0 equals to 0. That means X equals to 0. So the oxidation state of nickel in this complex is 0. Now the second example, the next example. So for this, the oxidation state of chromium Bx and plus 4 water molecule and plus 2 Cl. Now the overall charge will be, we have to put this plus 1. Firstly we have to break the ions, break the molecule, and then we have to put the sign, means oxidation state for the particular molecule or the atoms. Now X plus, for water molecule charge will be 0, and for Cl minus 1 equals to plus 1. So X 4 into 0 0 and 2 into minus ka 2 equals to minus ka 2 equals to plus 1. So X minus 2 equals to plus 1. X equals to, very simple, minus ka 3. The oxidation state of chromium in this complex is plus ka 3, plus 3. Now for this complex, let the oxidation state of cobalt be X plus 3 into ammonia plus 3 into Cl. So overall charge will be 0. It is neutral molecule having no charge. Now X plus 3 for the ammonia charge will be 0. Ammonia is a molecule, and molecule always a neutral species. And 3 Cl charge minus ka 1 equals to 0. Now X plus 0 minus ka 3 equals to 0. So X will be plus 3. Now this example you can do this example, and you can put the answer in comment section. So definitely you have to do it. Okay, now it is very simple to calculate the oxidation state, and the oxidation state is very, very important because upcoming lecture will be the valence bond theory, and during the valence bond theory we will discuss the structure and the hybridization of the complex. So it is very important to learn how to calculate the oxidation state. Okay, thank you so much.